Okay, today we are going to go through the Crescent Girls Physics Prelim Paper 2014. So we are starting with Paper 1. Okay, question 1 is about the zero error. Like I said in class, I don't really rely on the formulas to get the answer. Here you can just use simple intuition to solve the question. So how I do it is that at the beginning you can see that the screw gauge has a zero error. You can't really close the screw gauge totally as shown in this diagram here. So you can see that there is an extra gap of 0.04 millimeter from this reading. So how you read it is that from here you get 0 mm, and then you look at the readings here. So you count from here 0, 1, 2, 3, 4. So this reading tells you that there's a 0.04 mm gap here. So when you use this screw gauge to measure something, you will get another set of reading. So when you measure the object directly, you get 0.98. But because you started off with this extra 0.04, logic will tell you that the actual reading is this reading minus of this extra 0.04 mm at the beginning. So that's how you get 0.94. So for some of you who are still not clear how to get the reading here, this is 0 mm. This pointer pointing down indicate that this is 0.05. So you have 0.5, sorry. So you have 0.5 here. Then after that, you proceed to read the readings from the sleeve here. So how you read it is always read from the bottom. So here's 45. You have to read the scale that is aligned with this line here. So you can see that this is aligned with this one here, the one that I draw. So it's 45, 46, 47, 48. So this 48 is actually 0.48 mm. So when you add these two readings together, you get the final reading for this particular figure. Then after that, you just minus off that extra 0.04 mm. Okay, question 2. Question 2 is about gravity. So down here is quite straightforward. It's kind of like a standard question. Remember your pendulum swing. Your pendulum swing depends on two things, gravity and the length of the string. So because there's a change in gravitational field, so definitely A will not be the same. Weight is dependent on gravity again. If you look at here, the height reached by the astronaut when he jumps with the same initial velocity. So down here, there's a few different approaches that you can use to analyze. I think the simplest one is to use energy conservation. So if the astronaut jump with the same initial velocity, meaning that by half mv squared, the initial amount of energy given to the astronaut from this initial burst of velocity will be the same. So we assume that this initial kinetic energy, when he reaches the highest point, it will be converted into PE, right? Gravitational potential energy. So imagine we all started off with 1000 joules of initial KE, and this thing has to be converted into gravitational potential energy totally. And because PE has the formula mgh, so if you use 1000 equals to mgh, you can see that the maximum height that you are going to get is actually dependent on the gravity as well. Yeah, so this for option D, it cannot be the same. So that's why you're only left with option C. So option C, you can see that is the changing in motion of a swinging can of water. But please take note, the subject of this statement is actually the easiness in changing the motion. If without this word easiness, then it is not going to be the same, because you can analyze this statement using conservation of energy, and you know that the swinging motion involves a change in potential energy, and due to that it cannot be the same. But with this word, the easiness in changing the motion of the swinging can. The easiness in changing motion is actually referring to your inertial. So inertial is not dependent on gravity. Inertial is dependent on the mass, the amount of particle of the particular object. So down here, the easiness in changing the motion is actually referring to inertial, and therefore it's going to be the same as long as the mass remains the same. So that's why C is your answer. Okay, for part 3, it is pretty tricky. I actually got it wrong in the first try due to a careless mistake. So what happened is that you know that from A to D, the car is experiencing an acceleration, meaning that the velocity is not the same. So I think for here, if you just use your intuition, you would know that the shortest time would appear towards the end, because the front you're still accelerating. So if you look at I will focus on between C and D and E. So C and D, you are still accelerating, and then D and E, you are already at constant speed. So imagine at C, you are already at 10 meters per second and you're accelerating, so you get maybe 15 and then 20 at D. And if you look at between D and E, you are consistently traveling at 20 meters per second. So just by listing down some numbers here, you will see that actually the average speed, or I would say when you are traveling from C to D, your speed is still increasing. So if you want to draw the speed time graph, you will get, let's assume that this is a uniform acceleration. You will get something like that, yeah. And if you look at between D to E, you will get something like that. So imagine that between C and D and not imagine, I mean it is a fact, between C and D and E, the distance to be covered is the same, right? So meaning that for this graph, if I were to cover let's say 10 meters square, I would need this much. But if I were to cover the same area using this line, I would definitely require shorter time, right? Because down here I have this empty space here. But when I'm having a straight line like that, I won't have any empty space. So therefore, in order to cover the same amount of area, I required a shorter time. So that's why your answer is D. Of course, you can use intuition and directly tell me the answer is D. I'm just providing you with a more mathematical approach. Okay? Okay, your question 4. Question 4, you would let's see if there's an easier approach to this. Okay, for question 4, you need to be quite careful. Now, the time whereby the two cars meet is not the intersection point, because most of the students would think that the time when the two cars meet is actually this intersection point. It is not. This intersection point just tell you that at this time, both cars are having the same velocity, because this is a velocity time graph. Okay, it doesn't tell you immediately the distance. So how do you interpret this statement when the two cars meet? Actually, when the two cars meet, it simply means that the area underneath the graph of these two lines will be the same, because they travel the same distance and therefore they will meet. Okay, so be very careful. This intersection point just tell you that they are having the same speed. So with the knowledge that area under the graph must be the same when the two cars meet, you can actually form this equation. Okay, what's on the left hand side is the distance traveled by car A. Okay, so the distance traveled by car A will be given by the area underneath this line. So it is a triangle, that's why you have half. The base, I do not know what is the base, I do not know when will the two cars meet, so I do not know what is the velocity. I also do not know what is the time when they meet. Okay, I just know that it will follow half base times height. Okay, and it will be equal to the distance traveled by car B. So car B is given by this line. The area underneath will be just a rectangular. So I know that the height will always be 4 meters per second. So that's why you have 4 here. And the time whereby they meet must be the same as this t, right? So I will have one unknown. So I have one equation here with two unknown, v and t. So I need to find another equation so that I can make v the subject of t. Okay, so what should I do? So if I look at the equation, the line at for car A, I notice that this question actually gives me information on 2 points already. One point is here with the coordinate 5, 4, and I have another coordinate here which give me the coordinate 10, 8. So with these 2 points, okay, on the line car A, I can actually work out the equation for my car A. So down here, I'm working out the gradient, and also of course you have this point 0, 0. So from here I got the gradient. Down here what I do is that I want to find out what is the equation for the line, so I just put some value here, v and t. So with this I will find out that, oh, my v can actually be expressed in terms of t. So I got a second equation here. I substitute back to this equation, so this v here, okay, I just bring this 4 over 5t into this v, and so I got this equation. So now I have one equation with one unknown, the t. So I do some algebra manipulation, I find out that t equals to 10. So I got this. Answer is C. Of course, what you can do is you can do try and error. You just take, okay, since the question gives me these few values, let's try it out. So some of the students will directly plug in, okay, I will try half, base 10, height 8. So you got this area, and then you try to equate it to the area under the line car B. And you will find out that, oh, the area is the same, and therefore it must be the answer. Another approach would be just by looking at the shape of this graph, you see that, oh, it is quite symmetrical. Seems like this area here can overlap with this area, and so you deduce that, okay, they must have met at time equals to 10. Okay, but if you use these two methods, try and error, or just by looking at the symmetry, of course you can solve this, but what if the question you encounter in your O-level is not symmetrical? Then you can't use that. So that's why I am giving you the more mathematic approach to this question. Okay? Okay, for your question 5. Okay, question 5, you are to change the velocity time graph into a displacement time graph. So first thing you need to take note is that you see that the velocity here is all in the positive region, meaning that the displacement must also be positive. Okay, because if you have a negative displacement, you divide by time. Time is always positive. If the displacement is negative, you will definitely get a negative velocity. So with that knowledge in mind, you can already cancel out B, because there is this negative part here, which does not make sense. So looking at this, you can actually break this velocity time graph into 3 parts. One is increasing velocity, constant velocity, and decreasing velocity. So when you change these 3 information into your displacement time graph, velocity is represented by the gradient in the displacement time graph. So when you have increasing velocity, when you translate it to the displacement time graph, basically you should expect increasing gradient. Okay, so A, C, and D, it is hard to tell whether it is a curve or is it a straight line. So since they all look the same, we cannot use this part as the determining factor for your answer. Then after that, we look at constant velocity. So constant velocity would be represented by a constant gradient in your displacement time. So again, you see that, oh, they all look like a constant gradient here. So again, you cannot use this information as the determining factor. So the last one is decreasing velocity. Decreasing velocity would give you a negative gradient, okay, in in your displacement time, sorry. It will still give you a positive gradient because your velocity is all in the positive region, right? So you know that your gradient in your displacement time must be positive as well. So if you look at A for this part, it will give you a negative gradient. So if this is the answer, the negative gradient will give you some negative velocity here. So A will not be the answer. Okay, so you are left with C and D. So you look at decreasing velocity, it will tell you that the gradient must be also decreasing. So if you look at C is a very clear cut that this is uniform gradient. So it cannot be uniform gradient because a uniform gradient will give you uniform velocity. Okay? Which in this case is not true. The velocity is actually decreasing. So if you look at D, you can see that it is quite obvious that it is a curve and the gradient is actually decreasing. So that's why the answer is D. Okay, question 6. Question 6 tests you on the Newton's law. So, a mass starts moving from rest and a constant force is acting on it. So because the constant force, that means there's a net force. So you expect it to have acceleration, and because the force is constant, therefore acceleration must be constant as well. Okay, then number 2 is an other way of saying it, what is stated in number 1, because acceleration is constant, right? So velocity must be increasing at a constant rate. So number 2 is also correct. Now the thing about part 3 is that you do not know, okay, whether this distance travel is directly proportional to time. In fact, it's not true. Okay, this would only be true if the velocity is constant. Okay, if the velocity is constant. If you are good in mathematics, you can translate this English statement into mathematics. So distance directly proportional to time. You have D directly proportional to time. So if you write it out in mathematics, it will be D equals to KT. So if you look at this K here is actually equals to your speed. So it cannot happen this way if there is acceleration. Okay, so that's why number 3 is wrong. Okay. Okay, number 7. Which arrangement will give you the greatest acceleration? So your acceleration is dependent on your net force. Okay, so the greater the net force, the greater the acceleration. So if you look at all these arrangement, okay, only in part A you will have both force acting in the same direction. So there will be no cancellation of force. Okay, the forces are all pushing in one single direction, and therefore your A will give you the maximum net force. Okay, some of you who choose B and C, yes, the 10 Newton does not cancel out each other like in D, but you can see that they are acting in different direction. So if you draw your vector diagram, let's say I will just sketch out part B. So part B, you have the vector diagram this way. So I will use the tail to head method. So this is your first 10 Newton, then after that the second vector, another 10 Newton. So the net force will be this way. Okay, and if you use your, because this is 90 degrees, right, you can use your Pythagoras theorem, and you will see that this thing can never be 20 because this guy will be square root of 200. Okay, it will be less than 20. So B and C won't be your answer. Okay, question 8 is a bit tricky. Tricky in the sense that the language used for the 4 different options. I think A is pretty obvious that it is wrong because it says that the box is resting on the ground. It means that the net force is 0 because acceleration is 0. So Q, the downward acting force, must be equal to the upward acting force Q must be equal to the downward acting force of P and R. So it shouldn't be larger than, it should be equal. Now part B, P is the push of the box on the earth. So the problem is with the last part of this statement, on the earth, P is actually the weight of the box, and the weight of the box is actually coming from the earth, not on the earth. So how to correct this statement would be P is the pull, okay, of the earth on the box, right? P is the weight, right? So it is the pull from the earth on the box, okay? So the subject here is wrong. Okay, option C is Q is the pull of the box on the earth. So Q here is actually the upward reaction force, okay, from the earth on the box. So again, is the subject here that is giving the problem. Okay, D is the push of the person on the box. So, R. So R is the push of the person. So the weight, they rephrase it in terms of, they model it as a push. So it's still okay. Of the person, so it's correct, it's from the person, and it's acting on the box. So every part of this statement is correct, so that's why D is your answer. Okay, 9. 9? Nine is about your density and your flotation. You need to have the concept that the lighter the density, the higher it will float. So just work out the different density here and then just rank it accordingly and you get your answer. Okay?